Alright, good morning scholars, this is Mr. Intunza with you. We're going to go ahead and start working on some more examples, which is example 1 from section 3.4. So we're going to continue with this whole topic of logs. So by this point, it is very important for you guys to understand your properties and know how to manipulate them so that we can actually solve some equations. So that's what we're going to try to do now. Notice on this first one, we have 2 to the power of x equals 32. And now, some of you may be able to look at this and just do it off the top of your head, which is nothing wrong with that. However, let me show you what's going on behind the scenes. Okay? First of all, you will notice that 32 is actually 2 multiplied several times. So in other words, we're going to take 32 and rewrite it in this same base right here, base 2. Okay? So here we go. So this left side, we technically haven't done anything. On the right side, we know that 2 to what power is 32? And let's see, 2 times 2 is 4, times 2 is 8, 16. Oh, it's going to be 2 to the 5th power is 32. Now notice, this is a 2, that is a 2. So our one-to-one property says my answer is basically 5. And we're done. So there's the first one. Now let's go through the second one and see what we have. On this one we have natural log of x minus natural log of 3. And we're going to try to go ahead and solve for x. So let's try to see what we can do. So on this first one, notice that this is being subtracted from that. Therefore, we could add natural log of x or natural log of 3x to both sides. So we end up with the natural log of x is equal to the natural log of 3. Now notice, these are the same. So what happens to my natural log and my natural log? You use the one-to-one property again and you end up with x must equal 3. Now, use your common sense. You want the left side to be exactly like the right side, so obviously x is going to be what number? 3, which is basically the one-to-one property. Okay? Now let's go over here. This one looks a little bit trickier because you have to do a little bit of number manipulation before we actually solve it. First thing we got to do is, notice that this is a 3, this is a 9. But luckily for us that we can turn this 9 into 3s with an exponent, of course. So let's see what we got. First of all, we know that 9 is the same as 3 squared. Correct? 3 times 3 is 9. Now, this number up here, notice is 1 over 3 to the x. So let's go ahead and make this number with this same base right here, or the 3. Okay, so let's turn it into that. Well, notice that the 3 is on the bottom. When the 3 is on the bottom, that means that it must be a negative exponent, right? So let's rewrite it. This is the same as 3 to the negative 1, but notice your x times x right there, right? Now, once again, our one-to-one property, or notice that, what does this need to be to make that a 2? These are the same, right? So, this gives you negative x equals 2. Divide by negative 1, and x must equal negative 2. Okay? And this one over here, we have e to the x equals 7. Now, we're going to have to get a little bit creative here because, remember, we want to get rid of the e so that we can have the x nicely all alone, right? So, in order for this to go away, remember that in base e, we have the natural log. So that's what we're going to do here. We're going to take the natural log of the left, and then we're going to take the natural log of the right. Because remember, this is still an equation. Whatever you do to the left, you got to do to the right. So here we go. Take the natural log of the left, natural log of the right, and notice they're still the same because I did the same operation to both sides, or the same thing to both sides. So, notice, this is natural log. We never write it, but the base is e. This is also e, so remember your property. Your property on inverse property says that if this base technically is e, like I said, and this number is the same, they're both e's, then we can get rid of that and say that all of that is the same as x. So x equals natural log of 7. Now, you could just simply turn that into a decimal, and then you will be done.